Good morning to everyone. I'm Benedetta Costa, and today I would like to present my PhD project that concerns about the design of a sustainable binder for the consolidation of old masonry in Vienna through an injection process. First of all, I would like to briefly present myself. I did both my bachelor and master degree in the University of Padua at the Department of Geosciences, and after that I had the possibility to work for more or less 1 year and a half at the University of Padua in collaboration with a spin-off of the university called Opigeo, and there I had the opportunity to start to work more in detail with the building material field. After that, since September, I'm a PhD student at Wien. Let's start with my presentation, and as I told in the title of my presentation, I'm working with the historical buildings. In particular, my building belongs to Gründerzeit period, which is one of the main important period in the whole Austria. But I'm today with my presentation, I will be focused especially in the city of Vienna. Gründerzeit started in 1840 and going on until 1950. And during this period, we have two important points that characterize the Gründerzeit. I'm talking about a strong development of the communication path and also a strong economic expansion. For this reason, the opportunity of the city of Vienna that was able to offer at the people was very good in terms of job. And so for this reason, a lot of people decide to move from the countryside to the city of Vienna in order to improve their life. Indeed, at the end of the Gründerzeit period in Vienna, we had about 2.2 million of people that lived there. And for this reason, the landscape of the city changed a lot, and they rise up a lot of buildings in order to host all of these people. Masonry buildings were not important only in the Gründerzeit period, but they are also important nowadays because they still represent a home and a workplace for more or less 1/3 of the Viennese people. And just to focus your attention, nowadays in Vienna we have 32,000 of masonry. And so, as I told you, they are still a home and a workplace for these people, and so it's important to continue to take care about this kind of building in order to permit to these people to live in the better condition possible. These buildings are historical buildings, and they are protected, especially in the center, in the city center. And moreover, another problem that we have in the center is that we don't have space to build up new building, and so we try to work with the old one. And usually, what happened to masonry is reported here. This is an old photograph, and this is a new one. And as you can see, the building company simply remove the old roof that is made in a very easy way with the slab wood, and create a new extra floor and a new roof, as you can see here. And this means that the old structure should be able to carry an extra load. And in order to do this, the old portion should be consolidated in a very good way. Nowadays, what the building company do is try to consolidate the old portion of the building, injecting epoxy, and they inject this kind of material in the cellar part using this kind of setup. What they do, they simply drill and they make some hole in the wall with different angle, and they insert into this kind of hole this particular type of screw that they call packers. Packers are empty inside, and they simply inject epoxy into them. After the consolidation, they just cut the external part of the packers, this green part here. Instead, the part that it's into the wall remain in situ. So why they continue to use epoxy? They use epoxy because for sure it works very well. It's able to give mechanical property, good mechanical property to the wall, and moreover, it's able to it's easy to handle and it's easy to work. So at this point, where is the problem with epoxy? If it's work very good, the problem is that epoxy is not an eco-sustainable material, especially because in any case, even if these buildings are protected and they are a symbol of the city of Vienna, quite often they are demolished, and moreover more or less every year they demolish 1% of the previous 32,000 of this kind of building. I mean, for sure, not of all of 1% is Consolidate, but a part of them is, a part of them are. And when they happen, they are not able to split up in any way the two component of the masonry, and I'm talking about bricks and mortar, and they just need to throw away everything without recycle any kind of material. Moreover, another important point is that the intrinsic property of this kind of building, talking about permeability, are very different respect the epoxy. And so the contact with these two materials in some case can create more damage than benefit. And so what I'm trying to do with my PhD is just trying to find a new binder that it's that work well as epoxy from a mechanical point of view, but also that it be able to be that permit to the material to be recycled. For this reason, I start to investigate water glass or sodium silicate. As reported here, you can find the molecular structure of a sodium silicate in solution. And as the name saying, the sodium silicate is composed by two main parts, SiO2 and Na2O. And the ratio between these two components is very important because affect several parameters of sodium silicate, but in particular, it affects viscosity. And as I told you, if I want to have something that is able to be injectable into the masonry, is a very important parameter that I need to keep in mind. How the viscosity is affected by the molar ratio? Here I reported the case in which we have an higher molar ratio, and this means that in our system we have a lot of SiO2 respect the sodium quantity, and in this case the SiO2 start to link each other, and the structure start to polymerize and is very well organized, and for sure in this way we have an increase in the viscosity. Instead, if we have a low molar ratio, we have more Na2O respect silica, and in this way the creation of the nectar is reduced due to the presence of sodium ions inside the solution. So here, in a schematic way, I reported the trend about how viscosity change in function of the quantity of sodium on silica. And it's important to keep in mind, as I told you, that for me it's important to have a material with a low viscosity, but at the same time, it's also important to have a material which contain enough SiO2. And why is reported here? Because I would like to use this kind of reaction in my masonry in order to create CSH, that, as all we know, it's the main reaction product after the hydration of Portland cement, that it's able to give the strength at the cement. And so I would like to recreate the same reaction also in the old mortar. So in order to investigate and to predict how this kind of material can react with the old mortar, simply what I did is start to study in detail the composition of the mortar. In order to do that, I started to study directly from the building size, and I mean in a bigger scale, and study deeply until to reach the micro scale. Thanks to the collaboration of Pour Industry, I was able to go directly in the building site and to see how the workers usually work and how they are able to pick up the core from this kind of building. As I told you before, these buildings are still a home for a lot of people, and so for sure I cannot have a lot of material to work on. So I will exactly. So I was quite lucky because I was able to obtain just 2 core, but I mean it's not a super quantity of material. I try to do my best to work with this quantity, and the first thing that I did is just to remove the mortar from the bricks manually, and I remove the aggregate using a sieves column. And after that, as all we know, and also in literature is the port, the real binder is considered that material that it's able to pass a 63 micron. But where is the problem? If I'm working this way, in my case, I was not able to save a lot of material to continue my experiment. So I was trying to find a solution to save much material as possible. And in this case, rheology, and in particular case, SAUS helped me a lot. I don't want to talk a lot about this because my supervisor, Teresa Riberto, already did yesterday, but just to give you some information, what I did with rheology is just to create a different paste with different granulometer size and analyze the residual activity. To analyze the residual activity, I did a time structuration test, and the residual activity is represented by the slope of all of these three curves. And as you can see, the fuchsia curve, it's a bit present a slope a little bit higher respect the other two, because in this case, it's represented from the more reactive part, I mean, the real binder, less than 63 micron. But if you take an overall view of all of these three lines, the difference is not so big. And so for this reason, I was able to collect all the powder that was able to pass at 250 micron, but without lose the reactivity of the powder. After that, I start to analyze in a very detailed the mineralogical and the chemical composition of the powder, because in this way I was able to understand the reaction between the water glass and the powder. In order to do that, I work a lot, and I'm working a lot with X-ray D powder diffraction. I work a lot with this kind of instrument in Padova, and I'm trying to do it the same in Vienna, where we have a powerful center, but unfortunately they use this kind of instrument to work for a different, to work especially in catalysis, and they are not used to work with cement and polycrystalline phase as mortar and so on. And so I'm trying to fix everything in the best ways as possible. And here I reported the main optical component that I used to do my analysis. To prepare the sample in the X-ray, to prepare the sample, I mean, if you want to have a good analysis, is also important the way in which you prepare the sample, because X-ray D works in a very detailed way if you are able to have a powder less than 50 micron. So what I did is just grind the old mortar and mix the old mortar with a small quantity of internal standard, because in this way I was able not only to obtain the mineralogical phase that belong to my sample, but also to quantify all of them. I prepared the sample with the backload method charge, and I simply analyze the sample with the diffractometer in reflection and Bragg-Brentano geometry. After that, here I reported the result of my analysis, and as you can see, I was able to found two principal phase. The blue one is related to calcite, and this represents the real binder of my mortar. And moreover, I was also able to detect quartz, muscovite, feldspar, and other minor phase that instead are related to the presence of the aggregate in my mortar. And moreover, to go deeper with the chemical analysis, I also did some X-ray XRF in order to know the oxide composition of the sample. And as you can see here, the results that I was able to obtain are in line with the result related to X-ray D. And so put together all the chemical analysis that I did, plus some research in literature, I was able to identify, to classify in a better way the mortar that I'm working on. I'm working with a higher hardening mortar, and this means that at that time when decided to build the building, the main reactive part was represented by Portlandite, that it's able to react with the CO2 that is present in the atmosphere through a carbonation process in order to form calcium carbonate, which is the main mineral that gives the strength at that kind of mortar. And this calcium carbonate is the same calcium carbonate that I was able to detect. After that, in order to characterize and go deeper with the analysis, I did also an acid attack. I use chlorhydric acid with 2 molar concentration, and I try to test the mortar with 2 different paths. The same one using always 2 molar concentration acid chlorhydric, but in a boiling solution for 30 minutes. Instead, in the other way, in the other case, I use also 30-minute test, always in a stirring with a stirring method, but with a temperature, with a solution at the temperature, at ambiental temperature. And as you can see here, the result that come from these two different type of tests are more or less the same. And I was able to obtain a binder aggregate ratio about 1/3, which is quite common use also nowadays in the building site. And to validate my test, because for sure I need to be sure that all the calcite, all the binder present on the mortar is removed in order to have a good ratio between binder and aggregate. And so to do that, I use again XRD. And as you can see here, the results that come from the test at the environmental temperature and the hot temperature are more or less the same. And I would like to focus your attention on this green line, because they represent the position of the peak of the calcite, of where calcite should be located if in my sample I still have calcite. And as you can see, they are not present anymore. And moreover, the red line represents the main characteristic peak of calcite. And so as you can see, is not present. And so this means that the concentration of acid that I use and the procedure that I use was correct. And why I did all of that? The reason is simple, because as I told you, I don't have a lot of material and I need to go on with my research. And so what I would like to do is try to create a design mortar model that permit me to going on, especially with the injection, because this is one of the main points of my research. And I need to test and to discover how exactly react with the old mortar. This again, this is the reaction that I talked you before, and I would like to focus your attention for 1 second about the calcium source. Now we are sure that in my material I have calcium because I have calcite, but where is the problem? The problem is that the calcite in water solution dissolve in a very slow way, and so I would like to have something that permit me to work with this reaction in a more fast way. And so what I did is just add again a small quantity of calcium hydroxide. How I add this kind of material? All the samples were prepared manually, because as you can see here, I work in a very small scale. And so I just mix the mortar and calcium hydroxide with a small ICA tube. And here I reported the receipts for all of the 3 batch that I used. And in the red part, you can see the constant ingredient that I use for the 3 batch. And in green part, the calcium carbonate that I add as an extra phase in 2 of 3 batch. Here I reported in detail all the quantity, the concentration, the ratio of water glass, and the quantity of calcium carbonate that start to 0% until 5% in weight. And I prepared the sample. After 4 days, I was able to test all of them with a compressive strength test. And as you can see here, is possible to see a quite clear trend related to the increasing of compressive strength test in function of the quantity of calcium carbonate put inside. All of them, in any case, contain always the Portlandite. And as you can see, the sample with higher quantity of calcium carbonate is also the sample that it's able to reach about 2.3 megapascal in terms of compressive strength test. After that, just to briefly summarize my presentation, I would like to underline once again how SAS can be a powerful technique that helped me a lot to save a lot of material. And moreover, I would like to underline again the importance of chemical analysis, both XRD and XRF, because they were used to characterize the mortar, but they are also used now because as I told you, I would like to recreate this model of the mortar, and it must be similar in all point of view for the composition and for the binder aggregate ratio, and also the mechanical test, because in this way I'm able to understand in a better detail exactly how water glass react with my material. Last thing, I'm sure that I need to characterize more deeply the mortar from a chemical point of view, but as I told you now in this month, I was working on that to recreate at the end this sort of small wall in order to inject directly, as reported here, and to see how it works. Because I mean, water glass for sure, it interacts with mortar, but not only with the mortar, also with the bricks. And so I need to investigate that more in detail. And to help me, I have the pleasure to work with Antoine Pauline. She is a civil engineer student from ENSTA in Paris, and she will be with me for the next 3 months to work on this kind of project. Thank you so much for your attention.
Thank you very much. Do we have questions? Yes.
Thank you. Well, excellent talk. Thank you.
Thank you so much.
Well presented. Just small question about the water glass. So I think, did you try to use polycarboxylate superplasticizer to reduce the viscosity?
No, I didn't try, but it should be.
It might work.
Honestly, I'm not able to reply to you because, as I told you, I didn't try. I mean, I think that with water glass itself, it cannot work. But yeah, I need to try because I don't know.
Again, I think I used water glass with superplasticizer naphthalene, and it was sort of working well, but I cannot really speak for polycarboxylate, but it might be interesting to try.
Yes, sure.
Also, if you like to vary the composition of water glass, you can try nanoparticles. Silicon dioxide nanoparticles may work also well.
Yes.
In this system. So
yes,
this is just suggestion.
Yeah, no, sure. Thank you so much. Because yes.
Well, thank you so much.
Thank you too.
Talk.
I don't know if there are other questions. For me, I was wondering, like you said, you don't have a lot of material because you have to get them in the houses. But can you recover some of the demolished materials, like from the houses that have been demolished?
Sorry, could you please speak a bit higher?
Okay.
Thank you.
Yes, it's on. Yeah, I was wondering, like you say you don't have a lot of material to make the analysis, but can't you get some of the material from the houses that have been destroyed or demolished?
Yeah, the point is that when they demolish everything, they mix a lot of stuff. And also sometimes they try to, I mean, this kind of, I didn't say, but this kind of building usually have a lot of problem also for what concern the moisture. And sometimes they used to fix this kind of problem, injecting some foam. And so if I try to collect the material from the demolition site, sometimes it's not pure. And so it's contaminated from all of the other material, this kind of foam. Sometimes they use cement. And so I'm not able to have a very representative sample of the real mortar.
Okay, thank you. Question? Yes.
Thank you for your talk. I was wondering, at the end you mentioned that you wanted to investigate the bricks at some point, but the bricks are, I mean, they will last forever. No, the weak thing is the mortar. Am I right to say that? You don't have to care about the bricks. The brick will kind of last forever, no?
I don't know, because I think that probably there is some interaction between the water glass and the bricks. And I'm not so sure because, I mean, I need to see.
You mean the interface between the
yes,
two? Okay.
Exactly.
Okay.
Exactly.
Yeah,
exactly.
Sure. Okay.
Yes, this is for sure.
Okay. Well, you have other questions? If not, I think we can thank Benedetta again.
Thank you.